Okay, let's look at number 4. Number 4 is asking us draw the final product from the following 6-step reaction sequence. So very, very long question here. So I have, this is an organic chemistry problem here. So let me just draw the structure here. And then I have basically 6 steps here, so I have quite a bit. So first one is NaOCH3. So again, some type of base here. And then I'm going to add an alkyl chain of BRs. Let's 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, that's good. And then 3 will have NaOCH3 again. 4 would be an a lithium aluminum hydride oxidation, or sorry, reduction, water, and then some type of ketone with a tosyl group as our catalyst. Okay, so we have a lot of steps here, so we have to break this down into a couple of steps. And actually, for the sake of time, I might actually just look at the solution to just verify that the solution exists, and then kind of reverse work our way back here. So the solution that they provided here is this, but they didn't provide a specific analysis here. So let's kind of work this out here. So the first kind of step here, what I'm doing here is I'm deprotonating something here, right? So in this case, this is sodium. The sodium here is going to deprotonate a specific some type of hydrogen atom. In this case, it's going to actually deprotonate this step here, because this here is the alpha carbon between 2 carbonyl groups. So so if I were to deprotonate this one, I would get a negative. I would get basically a hydrogen would be removed here, and this guy would be kind of a negative. There would be a negative charge on this carbon here. Then our second step, it would actually attack this bromine here, right? I know that this guy here is partial negative, and this here would be partial positive, right? So this guy is going to come and attack here, and then it's going to kick out this bromine here. It's going to form some type of bromine chain. So let me try to draw this out for you. And I don't really want to spend that much time on this question here. So let me see if I can draw this out again. So O, double bond O, bond O, and then I have basically I have 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, and 5, and then and this is actually symmetrical. So I have 1, 2, 3, 4, 5, and then I would have my BR here. And then what it's going to do again, I'm going to then repeat the same process, right? I'm going to again deprotonate a specific carbon here, and I'm going to add add something to it. So I'm going to deprotonate here. I'm going to deprotonate again the same carbon atom here. So one of these guys here is the hydrogen is going to be removed. So I'm going to have a negative charge on here again, and then I'm going to use lithium aluminum hydride to reduce this compound here. So when I reduce this compound here, I'm going to start making this cyclic group here, right? So if I reduce this compound, I'm going to basically eliminate these ester groups here. So I'm going to get basically just let me just see if we can draw this out here. I'm going to remove these ester groups. So I'm going to get something like this. So it'd be a double bond O, and this is simply bond H now. Double bond O, choose bond H, and then I have my the alkyl group here. So 1, 2, 3, 4, 5, and then our BR here. I'm using a water workup here, so this is going to be a substitution between this BR here. So I can simply this here would become it would do an elimination, and maybe I would actually reduce this bromine into an alkene. So this guy would be removed, and this carbon's also removed here. or sorry, 1, 2, 3, 4, 5, and this we have a double bond here. And then what it's going to do is going to, with this compound here, this ketone here, and with the tosylate group here, it's going to basically form our cyclic group. So let me show you how it forms here. So again, I have here, this is this is a 6-membered ring here with my 2 carbons here. So I have, again, our 2 carbons here and our 6-membered ring. So 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. So this here would become our ring, and this here would become our kind of the acetyl groups here. So this here would be our solution for this problem. So this here is actually the correct solution. Let me see. What this is going to do is actually going to add. I'm going to basically protect these groups with tosylate groups here. So these guys here become I'm adding basically an extra carbon here, so it produces these 2 guys. It's going to bring these methyl groups back here, so I form these 2-membered rings here. So this solution here is correct. And again, this here basically I create a ring with these 6 carbons, and I get the acetyl group with these 2 carbonyl groups here. So this solution here is correct. Good analysis here.